Okay, let's look at these last two examples. For example 5, we're back in factored form. We can see that if we were to multiply this out, the leading term would be negative x times x squared times x. So this would be negative x to the fourth plus some other terms. So the leading term is negative x to the fourth, so that means f behaves like minus x to the fourth as the absolute value of x gets large. And what are the zeros? Well, we can replace this 5 minus x with negative 1 times x minus 5. And we can also factor x squared minus 9. We can factor as this is a difference of two squares. This is x plus 3 times x minus 3. And then we have x plus 1. Okay. We can see that we have 1, 2, 3, 4 distinct linear factors. So we're going to have 4 zeros, each with multiplicity 1. Right? We have 5. Negative 3, 3, and negative 1. So we are, and we're going to be crossing everywhere. Because the multiplicities are odd. And the x-intercepts, we can see that we'll have 4 of them, right? And x equals 5, negative 3, 3, and negative 1. What will be the y-intercept? Well, plug in x equals 0, and we get 5 minus 0 times 0 minus 9 times 0 plus 1. This is 5 times negative 1 times 1. That's negative 45. Okay, so now I guess we just have to plot this. We plot our intercepts. Negative 3 is the least one. Then negative 1. Then 3. And then 5. Okay. We're starting at our leading term is negative x to the fourth. So that means as x gets large, this is going to be a negative. So we're shooting down on both ends. So we're just going to be shooting, starting down here, cross, 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 cross. So we have to turn around a total of 3 times. Okay. And remember, this is supposed to be negative 45. This is negative 3, negative 1, 3, and 5. So it should look like that. And again, this won't be drawn to scale. All right, let's look at example 6. Now this is factored, and something is very, you want to be very careful about this factor right here, x squared plus 1. But let's first go ahead and figure out what is the degree, what's the leading term. If we were to multiply this out, this would be x squared times x times x times x, right? So this would be x to the 5th plus some other terms. So f behaves like x to the 5th as the absolute value of x gets large. Okay, now clear what are the zeros. Well, before we do that, you might look like we could factor this, but we really can't. X squared plus 1. If it was x squared minus 1, we could factor. But x squared plus 1, this does not factor. This is not x plus 1 all raised to the second power. Okay, In fact, this is actually irreducible. In fact, because x squared, if x is a real number, x squared plus 1 is always going to be positive. This factor can never be 0. So there are no hidden factors in here. And in fact, this factor is kind of, you want to think of it as just fat. It's not really contributing anything to the polynomial except it raises the degree. It's just sort of there. So the only, because, remember, and again, way to think about this is if you just finding the zeros essentially means finding the x-intercepts. The only way that this product can be 0 is if one of these factors is 0, and this factor can never be 0. So the only zeros are 3 with multiplicity 2 and -4 with multiplicity 1. Okay, so this is even, so we cross. This is odd, so I'll try again. We touch because it's even, and then this is odd, so we cross. The x-intercepts will be at 3 and -4. What's the y-intercept? Plug in x equals 0. We get 0 plus 1, or 0 squared plus 1. 0 minus 3 squared, and 0 plus 4. I think this is going to be 1 times 9 times 4, which is 36. So y equals 36 would be the y-intercept. Okay, if we plot our intercepts, at least our x-intercepts, there's -4. Here's 3. And because we are starting, this behaves like x to the 5th. That means we're shooting up on the right, down on the left. Okay, so we are going to be starting down here, and we are crossing at -4, right? And then we're going to hit the y-axis at 36. At some point we're going to turn around and come down to 3, but at 3 we're touching, and so we're shooting up again. Okay. All right. So that's what we have. The turning points, don't worry about. We just need to know that it turns around somewhere. So in this case, we have 1, 2 turning points, but we could have had as many as 4 turning points because the degree is 5, but we only have 2. Okay. So we want to be careful about factors like this. Whenever you have a factor like x squared plus a positive number, that factor is not going to contribute anything to as far as x-intercepts or zeros are concerned.